Have you ever wondered why Mars, our neighboring planet, is red? Nestled as the fourth planet from the Sun, Mars earns its nickname, the Red Planet, from its unique reddish appearance. The red color of Mars is more than just a visual spectacle. It tells a story of the planet's history. The history of human interest in Mars dates back to ancient times. This enigmatic red dot, visible in our night sky, has been the subject of curiosity for millennia. Ancient Egyptians, for instance, were among the first to take note of Mars, recognizing it as a distinct celestial body. The Greeks, too, were captivated by this red celestial wanderer, naming it Ares after their god of war. Fast forward to the 17th century, the invention of the telescope marked a significant leap in our understanding of Mars. This invention allowed astronomers, for the first time, to observe the planet's surface in more detail. They could see the polar ice caps and began to speculate about the existence of life on Mars. Yet even with these advancements, Mars remained shrouded in mystery. Even with the invention of the telescope, it took centuries before we could start uncovering the secrets of this intriguing planet. In the 1960s, space probes began to unveil the fascinating details about Mars's surface and atmosphere. This was a time when humans had just begun to reach beyond the confines of our home planet, and Mars, with its alluring red glow, was a prime target for exploration. One of the key players in this era of Martian exploration was the Mariner 4, a space probe designed and launched by NASA. It was the first successful mission to the planet Mars, and its impact on our understanding of the red planet cannot be overstated. The Mariner 4 sent back the first close-up pictures of the Martian surface in July of 1965, giving us a glimpse into a world that, until then, had been seen only as a distant red point of light. These images revealed a surface that was both familiar and alien, with craters that resembled those on our moon, but also with vast, flat plains and towering cliffs. The Martian landscape was stark, barren, and beautiful in its own unique way, and it captured the imagination of scientists and space enthusiasts alike. But the Mariner 4 did more than just photograph the Martian surface. It also gave us our first insights into the Martian atmosphere. The probe discovered that Mars has a thin atmosphere, composed mainly of carbon dioxide with traces of nitrogen and argon. This was a significant finding, as it suggested that Mars had a climate and weather patterns similar to those on Earth. In fact, subsequent missions to Mars have confirmed that the planet does indeed have weather and seasons, albeit much colder and more extreme than ours. Mars experiences dust storms, frosty winters, and even occasional glimpses of clouds in its thin atmosphere. These discoveries sparked a renewed interest in Mars and fueled further exploration. They transformed our view of Mars from a distant red dot in the night sky to a world with its own unique geology and climate. A world that, in many ways, is not so different from our own. Perhaps one of the most exciting discoveries about Mars was the evidence of water. The story of water on Mars is a tale of intrigue and discovery, spanning decades of space exploration. It all began in the 1970s with NASA's Viking mission. This was the first mission to land a spacecraft safely on the Martian surface. The Viking landers sent back images of a dry, desolate landscape. Yet they also picked up hints of something astonishing, the possibility of water. Now, these weren't gushing rivers or expansive oceans. The Viking missions discovered traces of water vapor in Mars' thin atmosphere. It was a tantalizing clue, but not definitive proof, of water on the red planet. The idea of water on Mars lay dormant for years, much like the planet itself, until the dawn of the new millennium. Fast forward to the 2000s, a time of resurgence in Mars exploration. Orbiters like Mars Global Surveyor and Mars Odyssey, along with rovers like Spirit and Opportunity, began to provide strong evidence of past and present water on Mars. These missions discovered signs of ancient riverbeds and minerals that could only form in the presence of water. Even more exciting was the discovery of ice deposits just beneath the Martian surface. But the most compelling evidence came from the Mars Reconnaissance Orbiter, which spotted dark streaks appearing and disappearing on Martian slopes. These streaks, known as recurring slope lineae, are believed to be caused by the seasonal flow of briny water. This discovery was a game changer. Water is a key ingredient for life as we know it, Its presence on Mars not only changes our understanding of the red planet, but also stirs up the tantalizing possibility that Mars could have once harbored life, or perhaps may still do. The discovery of water on Mars opened up the possibility of life beyond Earth. This revelation continues to fuel our curiosity and our exploration of the red planet, reminding us that the universe is full of surprises waiting to be discovered. With the presence of water came the question, could there be life on Mars? This query has been the driving force behind numerous missions to Mars, each one inching us closer to potentially answering one of the greatest mysteries of our time. Let's start with the Mars 2020 mission, an ambitious endeavor that sent the Perseverance rover and Ingenuity helicopter to the red planet. The Perseverance rover, aptly named for its relentless pursuit of knowledge, is equipped with a suite of scientific instruments designed to search for signs of ancient microbial life. Its mission is to explore the Jezero crater, a place believed to have once been flooded with water, making it a prime location for potential past life. Ingenuity, on the other hand, has a slightly different task. This tiny helicopter is testing new flight capabilities in Mars's thin atmosphere, pushing the boundaries of what we thought was possible. While its mission isn't directly related to the search for life, its success could dramatically improve how we explore Mars in the future. Now let's talk about some tantalizing discoveries. In the past few years, Mars missions have detected organic molecules and methane on Mars, two key ingredients for life as we know it. Organic molecules are the building blocks of all known life, and while their presence doesn't confirm life, it does tell us that the conditions necessary for life to exist were present on Mars. Methane, too, is intriguing. On Earth, it's largely produced by biological processes, so finding it on Mars naturally piques our curiosity. However, it's important to remember that methane can also be produced by geological processes, so its detection isn't a smoking gun for life. While we have yet to find definitive evidence of life on Mars, these discoveries keep the search alive. Our explorations of the red planet continue to peel back layers of mystery, each finding a stepping stone on the path to answering the profound question, are we alone in the universe? The exploration of Mars is not just about understanding the planet, but also about our future. As we delve deeper into the cosmos, the idea of a second home in outer space becomes less of a sci-fi fantasy and more of a tangible reality. Mars, with its striking similarities to Earth, is a prime candidate for this ambitious endeavor. Plans for human missions to Mars are already in motion. Numerous space agencies and private companies are in a race not just to send humans to Mars, but also to establish a sustainable presence there. These missions aim to test our ability to live on another planet and to further our understanding of Mars and its potential to support life. However, colonizing Mars is not a walk in the park. It presents a multitude of challenges. The thin atmosphere, the cold temperatures, and the high radiation levels are just a few of the hurdles we have to overcome. But, as we've seen throughout history, humans are resilient and innovative. Potential solutions are already being explored, from constructing radiation-shielded habitats to developing methods for producing food and water on Mars. Living on Mars would mean adapting to a new normal. It would mean learning to thrive in an environment vastly different from our own. It would mean redefining what it means to be a human living in the cosmos. Whether or not we will call Mars our second home, the red planet continues to captivate us with its mysteries. As we look towards the future, the exploration of Mars remains a testament to our insatiable curiosity and our relentless pursuit of knowledge.